Good morning and welcome back. Let us discuss the parallel port interfacing with microcontroller 8051, and today we'll be discussing interfacing of LED and buzzer with the microcontroller. LED, these are the light emitting diodes, and if we have to interface the LED with the microcontroller, how we can do it? Basically, LEDs are used for indication, like if the output is high or low, that time the LED can glow. It depends on in what way the LED is connected to the circuitry will decide whether it will glow when the pin is high or pin is low. Basically, we all know that the microcontroller can sink or source a small amount of current. Typically, 8051 can sink 1.6 milliamperes of current, and it can source 60 microamperes of current. That means the LED can be connected directly to the pin as the microcontroller is capable of either sourcing the current or sinking the current. Now, when we have to connect the LED with the microcontroller, we have to take care of the uh, current which is carried by the LED. So we have to limit the current by using a current limiting resistor. Now in this case, the LED is connected in such a way that the anode is connected to the pin of the microcontroller and the cathode is connected to the ground. So in this case, to switch on the LED, you have to make the pin 1 high, and if you have to switch it off, you have to make it low. So when the pin will be high, that time the current will flow through the LED, it will glow. If it is low, then the LED will not glow. Unlike diodes, the LEDs have a forward voltage drop from 1.7 to 2.5 volts. Normal diode has zero point 0.7 volts as the forward voltage drop, but in this case the forward voltage drop is slightly more, and the amount of current that flows through the LED, the forward current, is around 10 milliamperes to 20 milliamperes. So in this case, how to calculate the value of this series resistor which will limit the current through the LED, let us say below 20 milliamperes, or let us take a simple case of 10 milliamperes. So the output of the microcontroller is say 5 volts. The voltage on the output pin of the microcontroller is 5 volts. The drop across the LED can be assumed to be 2 volts. And let us say I have to allow 10 milliamperes of current through it. So how will you calculate it? So this 5 volts, this voltage minus this drop divided by the current, which in this case is 10 milliampere. So 3 divided by 10 comes out to be 300. So the resistance required will be 300 ohm, or approximately it is 330 ohm, so that around 9 milliamperes of current will flow through the LED, and then the intensity will be quite okay. There is another way in which we can connect the LED to the microcontroller. In this case, the 5 volt supply is connected to the anode of the device, external supply, and then pin number 1 of the microcontroller is connected. Pin number 1 means pin number 1 of any port is connected to the cathode. Now in this case, uh, the microcontroller is used to sync the current. Now in this case, the microcontroller uh, will sync the current so that when the pin is 0, the pin 1 is 0, that time this 5 volt supply will allow current to flow through this LED, and then that current will flow through the microcontroller. So it will be syncing that current. So when the pin will be low, that time the LED will glow, and when the pin will be high, that time the both the voltages will be 5 volts and the LED will not glow. So to switch on the LED, you have to make the pin low, and to switch it off, you have to make the pin high. Now this is how one can connect number of LEDs to the microcontroller through a port. Now in this case, 8 LEDs are connected, and again in this case, the microcontroller has to source the current so that the LED will glow, because the anode is connected to the microcontroller pins, and the common cathode point is grounded. So whenever the pin is 1, that time the LED will glow. This is how the circuitry is shown, and then the other associated circuitry is related to the crystal, that is the clock generator, and then the second part is the reset pin, which is connected to the external circuitry, so that externally we can reset the microcontroller. This is a very simple program which is used to control the illumination of the LEDs, whether the LEDs will be on or off using this simple program. So initially what we have done, we have initialized port 2 for the output ports by outputting all ones to port A, and then port A, port 2. So accumulator is connected to port 2. These data on accumulator is moved to port 2, so that the port 2 will be output port, and then we have sent 0 1 as the data in port 2, so that only one LED will glow. So one by one the LEDs will glow, and then it will be like a dancing light. So initially LED number 1 will glow for some time. The time is decided by this delay subroutine. Then the data is 2, so that the second LED will glow, first will glow off. Then the third LED will glow, because now the data sent is 0100. Then we send the data uh, 1000. So fourth LED will glow, and so on. So alternately the LEDs will keep on glowing, and then depending on the arrangement of the LEDs in the string, either the LEDs will glow from right to left or left to right. So this is how the program is written. You can say it is the dancing light LED program. Then one more type of an LED is a bicolor LED. Bicolor LEDs often contain both green as well as red LEDs connected in inverse parallel. The meaning is that if the current flows in one way through the device, the LED will be uh, giving you the green color, and if the current flows in the other way, the LED will light red. So therefore, by using the source and sink capabilities of the microcontroller, it is possible to light the LED in both the colors. So in one case, the microcontroller will be sourcing the current. In the second case, it will be sinking the current. But in this case, externally, nothing is connected. Both the pins of the LED are connected to the pin number 0 and pin number 1 of the microcontroller. So when pin number 0 is 1 and pin 1 is 0, that time the red LED will glow. And when the reverse is true, when pin number 1 is high and pin number 0 is low, that time the green LED will glow. So the same is mentioned here. So to switch on LED in red, 0, pin number 0 is to be high, pin number 1 is to be low, and so on. So if I have to switch the green light on, then the 0th pin will be low and the pin number 1 will be high. If both are at the same potential, then nothing will glow. I can replace the LED by a signal lamp. Signal lamp is a simple lamp, a low wattage bulb. It can be also interfaced with the microcontroller, but the current requirement is slightly more in this case, so I have to amplify that current. So to interface the signal lamp, a standard transistor interfacing circuitry is used, and the circuitry is shown here. You can see that the different power supplies are used for lamp here. This is a 6-volt power supply, and this is the common point. So I have to make this ground or the 0 volts point, 0 volts rail common to the microcontroller power supply, so that the path will be completed. Otherwise this one pin number 1 output will not be connected to the transistor. So the common reference point must be provided. So in this case, if pin number 1 is high, that time this transistor will conduct and then this lamp will glow. If it is 0, the lamp will not glow. So the same is mentioned here. To switch on the lamp, the pin has to be high. To switch it off, the pin has to be low. There are certain tips here. If a battery is used as the power supply, it is worth remembering that LEDs draw much less current than the lamps. Lamp can draw much more current. LED, as I said in the previous case, 10 milliamperes is the current, which is the typical current which flows through the LED. In this case, the current can be high. So therefore, a simple indicator is required. If it is required, then LED is a better option because it draws less current. But in some cases, lamps are required, so there is no option. But when you have the power supply through batteries, then as far as possible, try to use LEDs to save the battery energy. Now, how to interface buzzer? Again, to interface the buzzer, we have to make use of the standard transistor circuitry. So when the pin is high, that time the transistor will be turned on, and then the buzzer will carry current, and then it will beep the sound. As there is an inductor in the buzzer circuitry, we are using this freewheeling diode to protect the transistor from high voltage when the transistor turns off. The inductive kickback it is called as. So again, in this case, the common point, this 0 volts bus is to be made common with the microcontroller common point. Again, in this case, if battery is to be used, then the piezoelectric piezoelectric buzzer draws much less current. So you can use a piezoelectric buzzer in place of the normal buzzer. One more advantage of the piezoelectric buzzer is that the normal buzzer will have only one tone, one beeping sound. Whereas the piezoelectric buzzer, it can sound many different tones. So that is one more advantage. It draws less current and it can create many tones. So that is the advantage of the piezoelectric buzzer. So this is how one can connect the piezoelectric buzzer or the normal buzzer with the circuitry. So in this case, the piezoelectric buzzer and the speaker, these are shown as the output devices which can be connected to the microcontroller. A piezo sounder or a speaker can be used to produce many different sounds, whereas the buzzer can only produce one single tone. The buzzer produces a noise when power is applied, but a piezo or a speaker require a pulsed signal to generate the noise. Fortunately, this is very easy to generate from the microcontroller by using the basic sound command. So by using the basic sound commands, we can generate different sounds. So this is how one can connect the microcontroller. This is the simple logic in which shows that if I have to produce a note of pitch 100 and of length 50 on pin number 1, then I can just write a command sound 1 comma in brackets 100 comma 50. 100 is the pitch, 50 is the length. And to produce a varying noise using a variable b1, I can write a simple program for b1 is equal to 1 to 100. This is the pitch, sound 1 comma b1, that is the pitch comma the length 25, and next b1. So you can increment, and then different tones can be generated by using the piezo sounder. This is all about interfacing of the LED and the buzzer. These are used as the output devices, indicating devices in case of the microcontroller circuits. Thank you.